Well, welcome here to the Scene Studio again, ladies and gentlemen. And this time on flight traps, I'm going to have a look at wires and other obstacles. Obviously, I had to lift out the wires a little bit because those are the ones that are mostly in the way where we want to go. All right, there's a lot of terrain strikes and there's a lot of other strikes, but I just felt that during this presentation, I must just highlight wires again. But let's get into it. And the first picture here, I just want to note that the story I'm relating to is not about this helicopter. All right, this is just a random photograph I've taken where I had wires and the helicopters in the same picture. So it's not associated with the wire strike about the game pilot that I've got to say here. But let's see what the game pilot said. He said, listen man, when I arrived in the area, I reconnoitered the entire place and saw the power lines that I had to avoid. Now, it means that he got onto the game farm and then he flew the perimeters and the area, doing a very good recce to see that he is on top of where will be the dangers and where not. So it is not like the very wires that we are talking about is now a surprise. They're not a surprise, it's known about. And then he says the following. He says, I then got busy with the herding of the animals. And the next thing I knew is when I woke up in hospital. And he said to me, what? How is it possible that you could know about the wires? So I said to him, and I don't really want to use his name, I said to him, but my man, are you telling me you knew about the wires? He said, yes. I said, okay, well, let's get this one down. You knew about the wires that you actually flew into? He said, yes. I said, now how's that possible? I mean, come on. You know. Well, it turned out that he got so busy with herding the animals, and what happened that there was one difficult animal who didn't want to go into the boma, and him and the animal started pushing. And it so happened that all his attention was on this animal, and in his periphery and in the back of the mind, the actual reality of the environment with the wire in just disappeared. That's a human factor, all right? It's got nothing to do with whether he's clever or not. This is the power of attention grabbing to take us away from the things that can actually hurt us. Right, so if I carry on here, obstacle strike. Now, I don't want it to seem that it's just for helicopters. Definitely not for helicopters. Remember, it's also for our low-flying fixed-wing brethren. So the helicopter operations by nature of the air vehicles facility and the application role provides obstacle opportunities 90% more than their fixed-wing counterparts, except for dedicated crop spraying aircraft. Here and there might be others that's low, but I can't get my mind around why there's really any other reasons for aircraft to be low, except if they're going to do some crop dusting. But there are more than one thing. There's crop dusting, there's game operations, there's, let's say, more intricate search where the helicopter's got to be really low level to be able to see amongst the trees and stuff like that. So, yeah, there's just many more reasons. And then, obviously, there's people that's there and they had no reason being there. Okay, helicopter-controlled flight into terrain. Okay, CFIT, controlled flight into terrain. Accidents are similar reasons as fixed wing, but with considerable more origins. Okay, so it is so. Probably half the accidents, in fact I have got the statistics only for a portion of type-specific helicopters, and there the main reason why there's a helicopter accident is because the helicopter makes contact with something that it shouldn't have made contact with. In other words, it's contact and then loss of control. All right. Now, loss of control, by the way, is the main reason why, or the number one reason for helicopter accidents. By the way, that's for the fixed wing, and I'm not talking about the wide bodies and the higher flying guys as well. What I want to say, and we need to come back here, is that helicopters just fly into masts, into trees, into wires, into the terrain, into anything, into something. And that's when sometimes you hear, I'll speak about CFIS, controlled flight into something. Now remember, that does not exist. It's just what I made up because it's a difficult thing to say. It's just not controlled flight into terrain. There's actually controlled flight into varied other environmental obstacles. Okay, 60% of helicopter accidents involve project strikes. Goodness, wire strikes are one of the most effective helicopter killers. And yeah, that is for sure. And then wires are the most effective and active microlight killers. So the microlight guys must also sit, and remember, they fly low because they can. Well, they probably shouldn't fly that low, but they do. And wires are the items posing the most dangers for crop dusting aircraft. Obviously, for your crop dusting aircraft, there will be the tree lines, which can pose serious problems as well, and it does. Yeah, I'm just trying to lift out that wires are so difficult to see that in most of the cases, the pilot will say, well, I entered the job and then I flew into the wires. And you would say, but why? Sometimes you would find that they didn't do a good reconnaissance before the time. Okay, that's one of the reasons. And then sometimes it just blows out the mind because we get so stuck into the work that we're doing. But we can't focus so deeply on a singularity while we're flying in a three-dimensional world. Think about that one. All right. Wires poses the biggest threat to low flight, even more so for fixed wing air vehicles due to the cockpit design. Now, what I said there is that if you look at the cockpit from, it's got a center stray, it's got side strays and stuff like that, the visibility from the cockpit outwards is more limited in an aircraft than that of a helicopter. In a helicopter, you can see quite a bit more. I'm not saying that's the main reason why they're flying into it, but if you're in a cockpit where there are many obstructions, and then the head movements will have to be considerably more, because, I mean, that's what it's all about. Everything must, there must be a flow on the lookout, on the left and the right. And then if there's a post and we look past the post, remember now that post is moving with you forward and the background moves. But if you continually scan, you've got a better chance. Just this little one thing, and I don't know why I'm throwing it in here, but it's very, no, I won't say it's seldom, but it's more probable that you'll pick up a power line system that's coming on the sides that will actually cross the path in the front. It's normally easier to pick it up on the sides and then eventually to see, okay, this is going to cross the flight path. But if I don't look out, I would never have had that indication of something that could go on. Natural and man-made object poses a serious problem for low-flying aircraft. What am I saying by natural and man-made? So remember now, when we start talking about obstacles, we're talking about the mountains, the trees, the buildings, the masts, everything. So whether it occurred naturally or whether it occurs after man interfered in the environment, as far as we are concerned, it's the same story. Then a little bit about external load. External load, external load obstacle strikes have a very high probability. Let's just think for a moment about external load. Okay, back to the helicopter now. The the external load on the helicopter is tethered, and it obviously is now part of the helicopter. All right? But it sits quite far. Maybe it sits 20 meters, 30 meters underneath the helicopter. And that, especially most of the helicopters, they don't have radar altimeters. And that really would help a lot, but because of the terrain that can change so quickly, that might not be feasible either. The point is that normally the flying is low. If you're doing survey work, it's low. When you do crop spraying, it's low. And here I'm not talking about external load. If you're doing cargo slinging, it will be low. If you do survey work with the slung underneath the helicopter, it's normally low-level work where you need to keep and maintain a certain height. And the problem is, if that, whatever you're swinging at the bottom, hits terrain, hits wires, you're going to have problems. All right, so there is a thing to say that solid obstacles or bounces from wires may destroy. So a solid obstacle strike is one thing, but also that I brought along is just this little picture here to show that if the bucket would hit the terrain, there would be a serious upswing. And as you can see, it's long enough so that the rope can actually get towards the tail rotor and entangle. Okay, now the guys who's doing firefighting, they will know that is a huge problem. But remember, that is a problem for any underslung load. All right, external load entanglement on trees, bushes, wires, that's for dynamic rollover. In fact, earlier years on the Alouette 3s, we had a gentleman and his flight engineer went out and they did some winching. So they winched down a bucket, a cement bucket. That was the weight, and that was practicing. And they actually put the weight in amongst the brushes. That already was not a good idea. But anyway, they did that. And then the pilot obviously moved slightly, which is, I think, pretty normal. But as they're moving now, all of a sudden the bucket couldn't come straight up, amongst all the brushes and stuff. And it actually entangled. So now you've got actually two options. If it entangles, then you've got to go back, lower slack, and see if you can wiggle it loose. Or you can cut with a squib. You should then cut the wire, the cable. They didn't do neither, and he flew further away, tried to pull it out. And when he tried to pull it out, the helicopter just went in. Typical dynamic rollover situation, there is absolutely nothing that you can do. Once you're past a certain point, there's no more recovery. And remember, you are now fixed to Mother Earth. All right, so I'm saying unbalanced or flying external loads, loss of control. That, by the way, I've seen also. I remember one of the gentlemen cargo slinging a car at one of the air shows, and he was flying a bit fast. And the next moment the car started flying, and the car was actually flying just about on his side. And they looked and said, "What?" And it was a little bit late at that stage of the game. I mean, the flight engineer, which they had on the aircraft, should have a long time ago said, but the car just started flying. And all right, they then managed to bank away, and they took the energy and they worked the energy in so that the two stayed on top of each other. If it was, again, a beginner, that could have been, easily become a tragedy. The thing with objects outside, if it can create flat plate lift, remember when we talk about these here, they will drag back, but they're round and symmetrical and all that stuff. But the moment that they become flatter and there is any indication of flat plate lift that's going to be preference on the one or the other side, the system will start flying. So don't just think of wings that are flying, But whilst we're at it, if you're cargo slinging an aircraft that's down out from a place, remember that you have to put a serious windsock, or anything that wants to be unstable, a serious windsock on the end. You have to put a serious windsock on the end so that it keeps the directional panels as you go forward. You have to do that. These things are probably easy to set, not so easy to be done. And, well, I once had to drop a telephone pole because it got so out of sequence and was swinging that whatever I tried to do didn't work. And I wasn't going to wait for it to kill me, so I jettisoned it. Much to the delight of everybody that was laughing at me. And yes, you come back with a red face, but a complete helicopter and everybody else is there. All right? So the training for external load and to get rid of those external loads, that must be paramount in the whole idea. What kind of types of wires have we got? Well, I've just got here power lines, guy wires. Those are the support wires. If there were wires on the side that support it, and many of the poles and masts have got that. And then communication cables. I just thought this was absolutely wonderfully cute. And then we get the fences, and the fences, let me do that in red, the fences, as I've got there on the farms, you know, it's never really considered to be an obstacle, believe me, to get your wheels hooked onto that, or the skids hooked onto that. I mean, that's just well, it's game over, because you are so close to the ground that these are all very, very legitimate obstacles. Yes, but the things are big and I can see them. Yes, they're big and you can see them until you cannot see them due to various reasons. So let's carry on a little bit. Just about the heights, you can see, I start off here with game fences, and now, you know, there are so many heights that you can talk about and that we can see, but roughly, if you get to your medium power lines, you're looking at about 80 to 100 feet. So you can see up to 50 feet. There is a lot of different stuff, but then the bigger boys come, and the high tension wires, 120 to 140 feet, and then you get those heavy duties, these big boys. They really go up to easily 180 foot. Lines across a riverbed is normally low, but lines across a canyon can be at any height. All right, so when I'm discussing the heights that we should fly, remember, if you fly in a ravine, then you cannot necessarily apply what I'm saying here, because you have high ground, and they can put a wire in between. So the heights that I'm referring to is, let's say, not in canyoned areas and, you know, inside that. All right, and let's just go back to that lines on the river. I see that so many times. So-and-so flew the lines on the river. Hello? Well, I don't know, you probably don't have the procedure, but there is a procedure that we use all the time to say, if you then have to go and fly low level on the river, you must first do a first-hand reconnaissance flight. You've recognized the whole area, and then once you've got onto the specific places where you want to fly, that's where you've then an overflight of around about 200 feet, and you check. And then obviously don't go low if you see wires. Prevention is for sure better than cure, because sometimes there's no cure. All right, so flight regime, and it's a very busy slide. So let me get into the slide by saying, here we have got the ground level, all right? And then you can see I've got a category 3, which is below 50 foot. I've got a category 2, which is between 50 foot and 100 foot. So, or it doesn't look like that, but this is also a 50-foot gap. Okay, I just needed more space to write and do things. Okay, so these two together, sorry, this gap is 100 foot, so this is 150 foot up to there, excuse me. This is the 50 foot, and this is double the height, it's 100 foot, so we're looking at a total height here of 150 foot. 150 foot, and then above that we get the category 1 or the normal flight regime. So we break the heights up, because when we start doing night vision procedures or dark night operations, you know, even with lights and we have to understand where the difficulty lies. And this is where I need everybody to pay attention, because there's a very, very natural height that you're going to seek if you're going to do low level. Most people, now look at this, and then I'll carry on with it. Most people, when they do low flying, I'm going to do it in red pen, they fly in this area between 50 and 150 foot. So if that's 150 foot and that's 50 foot, it's in this gap of 100 foot that they're flying. Anything above 150, in fact, we just say that anything below 200 foot is called low flying, and everything above we say is not low flying. They're building masts up to 800 feet high and 1,000 feet high. So I'm not saying it is obstacle free. When do we get to an obstacle free environment? Well, I said probably over 1,000 feet you can start thinking that the area is obstacle free. And that is then also called the two-dimensional world. What do we mean by that? Remember, the higher you go at 350 feet, it becomes like a flat earth society. You cannot see the obstacles, you cannot discern the heights anymore. The higher and the higher and the higher you fly, the less detail are there of depth. All right. But as you descend through 150 feet, the earth starts becoming a 3D environment. Depth perception in terms of the obstacles now becomes a reality. And obviously, the lower you fly until you get right here to the bottom, I mean, it's full 3D. Now, having said it's full 3D, not everybody flies in the 3D. You can think about the amount of information flow. By the way, if you take your fixed wing and you go and land on a game farm and you approach, you fly from the two-dimensional world into the three-dimensional world, and the moment that you get to the runway, it's all these trees and all, the flow of information has just become exponential. All right, so let me get back to my story. This area here, remember you've got your Cat 1 and higher, which in other words is deemed to be pretty safe, and for training purposes we work with anything above 200 feet. It can be acceptable. I sneaked in at 250 foot here. The only reason I put a little bit height is because it's difficult for us to maintain the same height, especially because you're not flying an autopilot height and you're flying, you know, above the earth. It means that 250 feet above the ground could vary with 50 feet easily. Okay. Then if you want to get down from this area and you want to come and land here, there is a transition area between the two-dimensional world. There's a transitional level towards the three-dimensional world. And remember that the three dimensions getting just very much more intensive the lower you get till you eventually land. Now, why I'm showing you this is to show that if I fly low level, I'm using that just to get our minds going. If I fly low level, then these wires that I've got here will be etched against the skyline. So there's the horizon, and I will see them above the skyline. Dead giveaway that they're there. If I sit a little bit lower, then less of them will be etched against the skyline. If I sit exactly where the skyline is, there's going to be no skylining of this obstacle. And in many times, some of the pylons are made of wood, and you've got the brown background, and voila, they just simply disappear. So if you're low, you've got a better chance of seeing them. If you're high, you're obviously not going to fly into them because they are there already. Okay, they're already occupying the space as we are talking. All the wires and most of the obstacles that you ever going to encounter in your life, they're already there. They're already occupying the space, and you're going to be the intruder into the space, lest you know that seat is taken. Okay, it's something like musical chairs, but different sort of, results. Okay, so in operationally low flying, we deem this area, wait, let me get this cleaned out, this area as very dangerous. This is, okay, let's say this is very dangerous, this is extremely dangerous, this is slightly dangerous, and these are not dangerous. And I'm not talking about the weather, okay? You get weather, bad news weather at 35,000, at 40,000 feet. You get bad news weather down at the ground. And when you get bad weather at this height, I mean, it just compiles to the whole thing. And that's when people sneak under the weather. They fly into the ground. They fly into the mountains. They don't know. Oh, I think we will make it. Really? Well, think again. Oh no, you decided on your feelings, and unfortunately you're not further there so that we can ask you, why did you make such a silly decision? Can't understand. All right, so this is the area that we want. We always need to go, if there's a runway there, we always have to approach, wherever we're approaching from, we've got to go through this area. Now I know the little drawing isn't the place, but just think of it. The most vulnerable, or the vulnerability, is exponentially increased the moment that you descend below 150 foot. Okay, this is where you must look out. Oh, Charlie, but all right, you're talking about the guys who are going to, but yeah, I'm doing crop spraying, man. I'm doing firefighting, and I'm doing fire bombing, and I'm doing game herding, and I'm doing cargo slinging operations and winching operations, and I live in this world. Okay? So when you live in the world, where do you work? And you can go and see, a game pilot will probably work up to maybe 100 foot above the ground. So at about in that level. When he's at that level, he's in trouble. But it doesn't matter. If his attention is away, then that is as well. But just to say that the operational area for the guys here lies mainly in this area. In other words, it is then partly in the extremely dangerous and the very dangerous. Here at the bottom, very dangerous, extremely dangerous, just because of the ability to see what's coming your way. If you're lower, you've got itch stuff, but then if you're too low, you fly into stuff. No. Well, yes, but the lower you fly, the more things there would be that you can fly into. I'm sure you're getting this one. All right. Okay, and now just to say that, avoid this area. Avoid this area. Your aviation dwellers out there who's flying low for the fun, the worst place that you can find yourself for low flying fun is between 50 and 150 foot above the ground. That's your most vulnerable. I'm not even talking about below 50 foot, because that is not an area where you really should be. If you do the odd shoot up over a runway, I can understand. It's clear, it's fine. Operationally, it's only the lucky and the charter guys that's got the privilege of runways. The rest, you can hardly call it runways. All right, doesn't matter. Here we go. Visibility. What is it affected by? Now, you know, do you call it a windscreen? Yes, you can call it a windscreen. It's on the canopy, no problems, and it's dirty. Why would you take off with a dirty windscreen? But if you are going, I remember years ago that one of my friends was doing, there was this locust problem, and they had to really fly and spray this area. And they have to actually get into the swarms. And what happens is that, you know, within a second or two or three, there's no visibility forward. Then you obviously got to fly through the window there, but there's no more visibility here. The moment you haven't got forward visibility, you better step it up. And what I step it up, I mean step it up to above 250 feet. Okay, water droplets on the windscreen, distorted windscreen, cracked, badly scratched, sand eroded, sun faded. Woo, that's all the conditionings of your windscreen. It's such an important part, and I'm not always sure that we pay enough attention to that. All right, then there's obviously light conditions. Is it dark? Is it light? And you shouldn't take off into the rising sun or land into the setting sun. Is it totally impossible? Well, not really. We used to look into the sun a lot for formation aerobatics. We'd have a pair of very dark glasses on, and then also the Polaroid Lloyd dark glasses on top of that. So we had double filters. And double filters, you can actually look at the sun. But that's not how we fly, all right? So with a windscreen that is slightly distorted onto the sun low on the windscreen, you are not going to see enough detail outside to do a good landing. Okay, obscuring effect by terrain. Remember that your pylons and your wires can blend. The rivers, and a lot of people say to me, why are there so many? I mean, they've got farms this side of the river and this side of the river. They've got lands this side of the river, this side of the river, and they need electricity down there. They need maybe a little slide that they want to go across for goods that they want to move over the river. There's so many reasons. They are there, okay? As we're speaking, they're already there. The ones that you may encounter in your future, they're already in place. And then there's going to be more, because they'll build a little bit more. But a lot of times, if you fly on a river, there's the trees on the sides, and you'll see that the poles or the pylons, they inside the trees now. And there's trees, and then just these very thin, 2-3 millimeter thick wire that comes over, and boy, normally you don't, well, if you see it, it's too late. All right, visual changes. Okay, we spoke about that three-dimensionally. I talk about crew attention span. This is extremely important. Where's your attention span? If you fly low level, your head's out. The best you can do is peep inside, but quickly, because 99.9% of your mind must be outside, because it's you and the environment. And guess what? The environment does not care about you. The environment will not give 1 inch Oh, it's new generation. Will not give 1 centimeter. All right? And so then you can look at the adverts and say, it just jumped in front of me. It has been there. It's been occupying that space. All right. No forgiveness, no giving way to you. And afterwards, who cares? Well, what cares, I should say. People will care a hell of a lot. But the things that are your primary problem is not going to care about you. Forget it. Optical illusions, they are acuity of the eye 2 degrees, and at 3 degrees you will lose the wires. Now let me just say what we're saying here. Your eye has got a 2-degree cone, and inside that cone, well, as you look at me, just look straight at me. Okay, thank you, everybody's looking. I am in focus. It's mainly not a nice focus, but I am in focus. Everything on the side is peripheral. It's not in focus. It's outside that 2 degrees. So now you've already got a wire which I can only really pick up, if I'm lucky, at the depth of focus of my eyes. If it is outside that 2 degrees, it becomes a fuzzy world with a fuzzy obstacle, and it will be missed. Therefore, the head must turn. We don't turn we turn a little bit ahead and we come back, but we're outside, checking all the time. Why? Because we must become situationally aware. Aware of what? Well, that is why we do this thing called threat and error. Threats. At this stage of the game, your error could be not to be able to see the threat. Your error could be not to be able to handle the threat. Just another way of thinking of it. All right. So when it comes to these acuities of it means so, and while we're at that, remember, if you start looking into the deep blue yonder and there's nothing there, your eyes will actually come back and focus about 1.5 meters in front of you. Now, some things are going to say 1 meter, 1.2 meter, 1.5 meter. It doesn't really matter. The focal point comes here. Okay? So if I look up in the sky and I stare up in the sky long enough, my eyes are going to go blink there. I'm focused there. How do we do it now? So now I look at a distant object, my eyes get focused, and I move it. And for moments, I've got focus there. I then look at it, something closer, and I look up, and I'm outside. I vary the depth of my field, my perceptive field, all the time, and then move it into an area where there is nothing. You want to see an aircraft flying. I can hear the aircraft, but I can't see him, because the sound has got a little bit of a problem. It is not traveling at the same speed. It's not traveling at, it bounces, and it's got a lot of things. So look at a sewer distance, look in the sky. Can't see it. Look at a distance, look in the sky. And you will find that aircraft, okay? That's what the fighter pilots taught me. All right. Wire sagging and tightening at the bottom, that is definitely part of that. Wire visibility is also the conditions. Okay, here you can see the conditions are pretty bad. We're looking at serious conditions here. Throwing it in close to the ground, it's such a different or dangerous environment. But here on the left, what has happened to the wires here? The thing is that when I look very carefully at the photograph, I can think I can see it, but I can't really see it. Okay, so the light playing and where we are, the focal length, all that stuff just makes this extremely difficult. It's time that we just acknowledge that there are certain human factors, not psychobabble, real design limitations. Okay? We can't talk this one out. This is how you built, these are your shortcomings, now work around that. and stop saying, you know, nonsense. All right. Now, attention distractions, and that happens outside and inside the cockpit. The one thing that you cannot do is to be distracted. It's in the cockpit here. I want to change a frequency at low level. Are you out of your mind? If the frequency is on and you fly low level, I know you can still talk to people. And look at that. We can do multitasking. We really can. But the main thing is that we see where we are. If you do not see, and the only way that you can see is by looking, but we'll do that in the next one. And then the next one I've got here, let me see, I said complacency. What is complacency? Everybody uses this word complacency. And there are many definitions. And through the years, I've come to I will only use complacency as to fall in set ways and to become seriously relaxed in an area that is actually dangerous. Yes, driving on the highway is dangerous. It's not the time to sit and do your lip stiffy and your phone calls and your eyebrows and picking your nose too much and all that kind of stuff. It's the time to concentrate on what's happening outside. So I'm riding on the highway and I see somebody behind me and I see they get busy there. I just move out of the way, my man. I don't want to be in front of that person. It is so dangerous. Now, the complacency means that we have become relaxed. I've done this 1,000 times and I'm just going to do it now for the 1,001st time. The fact that the height is slightly lower or whatever, or other factors that came in, they're going to catch you so by surprise, and normally that surprise is devastating. So complacency means we must not get all totally relaxed in a danger environment. We've got to be as up and go the first time as we were the first time during the last time. Okay. Right, this is then the end of the part one. We need to go and take a break now, and then we'll come back and we'll do part two. Do you need to do both parts? I think so, yes, because now we've got to start looking at obstacles and what this and. And there's still a lot to be said so that your minds can be changed in terms of obstacle avoidance. Until the second part.